All right, so this is on simplifying problems with factorials. So what you have here is a basic example of 7 factorial over 5 factorial. Now the problem here that you have is that you would expand it. So we'd expand 7 factorial, 5 factorial as such. 7 factorial is just 7 times 6 times 5 times 4 times 3 times 2 times 1, as you can see. And then 5 factorial is 5, 4, 3, 2, 1. And then because it's all multiplication, you can cancel. You can say, okay, so that cancels, that cancels, that cancels, that cancels, that cancels, which means the result is just going to be 7 times 6, which ends up being just 42. Now, imagine I ask you to simplify 24 factorial or 27 factorial. This probably not the best problem to work on in the same fashion. So you definitely don't want to do 24 times 23 times 22 times 21 and so forth. And the reason you wouldn't want to do that is it's going to take you a lot of time. You're going to have to go all the way down until you get to 2 times 1. And then you definitely don't want to do the same thing with 27. You go 27 times 26 times 25, 24. It's just going to take forever. But what you'll notice is that the larger the factorials can actually decrease until it hits the smaller of the factorials. What I mean by that is rather than expanding both of them, why not just expand the the larger one until you get to the smaller one's factorial range? Because we all know then that 27 factorial has 24 factorial embedded within it. What I mean by that is that you don't have to do it this way. You can just say, well, I know 24 factorial is on the top, and I know that the bottom has 24 factorial in it. I just have to figure out when it gets to that. So then I would say, okay, so that's 27 times 26 times 25 times 24 and so forth. And the so forth is essentially saying times 24 factorial. So now, since this 24 factorial up here matches the 24 factorial down here, these guys can end up canceling each other out, and what you're left with is 1 over 27 times 26 times 25. Now, I don't have a calculator, so I would just plug that in and get some fraction, but that's essentially how you'd simplify it. Now, how does this relate to something with a variable in it? Well, imagine we have something like n factorial over n plus 2 factorial. Now, what a lot of people get caught up on is trying to break these down. So some people would go, okay, well, I need to break down the n, so it's going to be n times, and then 1 less than n, which is n minus 1, and then 1 less than that, which is n minus 2, and then we don't know when to stop. But we do know that it's eventually going to go down to 3 times 2 times 1, because that's what all factorials end up doing. And then we can do the same thing with this guy. We can go n plus 2, and then we have to go 1 less than that, which is n plus 2 minus 1, or just n plus 1, and then n plus 1 minus 1, which is just n, and this is going to keep on going down forever until you get to 3, 2, 1, and then you go around canceling all those things. But there's a much faster way to do it. Just like we did up here where we had the 24 factorial and the 27 factorial, we could simplify just the 27 factorial or expand it, not simplify, expand it till we got it to the point where it hits the 24 factorial. So expand the larger of the two factorials until it gets to the smaller factorial. So on this one, we expanded 27 down till it got to 24 factorial because then it would have matched and they cancel out. We do the same thing here. The larger of the two is n plus 2. So rather than kind of breaking it down this way, what we can do is we can say, well, the n factorial is the smaller of the two, which means the n plus 2 factorial will eventually approach the n factorial. So it's going to be n plus 2 factorial is now n plus 2 times 1 less than that, n plus 1, which is, and then 1 less than that. And at this point, 1 less than n plus 1 is n, and this is going to keep going down. So rather than saying keep going down, so on and so forth, we just write n factorial. Now they both have the same exact numerator and denominator of n factorial, which cancels out, and we get 1 over the quantity n plus 2 times n plus 1. Now this works also if we have other types of other types of problems or factorials. For example, what if we had not just n, but let's say we had 7n minus 5 factorial over, and then 7n minus 3 factorial. And we approach it the same way. We have to ask ourselves, okay, which of the two factorials is larger? And I would say 7n minus 3 is the larger of those factorials. So what I'm going to do is I'm going to break down the 7n minus 3 factorial until I get to the 7n minus 5 going on forever. So it's going to be 7n minus 3 times 1 less than that, which is 7n minus 4 times, well, 1 less than that, which is 7n minus 5. And then when I get 7n minus 5, I can stop and say, well, I know it's going to repeat itself from there on. and so forth. And then we just get 7n minus 5 factorial on the top as well, because that's what it originally was. And then now these guys cancel out. Boom, boom. And we have 1 over the quantity 7n minus 3 times 7n minus 4. And that's it.